Okay, on to example 15 for enthalpy. In your notes, this is page number 11. All right, so we have a reaction here where we have 4 moles of iron reacting with 3 moles of oxygen to produce 2 moles of iron 3 oxide with a delta H value and release of energy of 1,652 kilojoules. Right? So now we're going to go ahead and solve this problem. Before we can do that, I want to talk to you about a few things. First of all, notice that this reaction is written as iron plus oxygen making iron oxide and hydrogen. Let me try that again. Iron plus oxygen making iron oxide with the delta H value of negative 1652 kilojoules. What we will need to do these problems is consider whether or not the reaction is in the forward direction or the reverse direction. So the way it's written here, we consider this going forward. To reverse it, I would simply write it the other direction. Therefore, then my delta H value will become positive 1,652 kilojoules. So when I reverse a reaction or consider a reaction in the reverse order, I must change the sign of the delta H. So here it's positive because it's the reverse. Here it's negative as it was written. So going forward, as it's given, that's considered forward, we have a negative value of delta H. If I reverse this, so I go from I make my products become my reactants, so I just wrote it in the opposite order, then my delta H has to become positive. All right, so I'm going to clear this and just talk about the problem now so that you can see how to work through these. First thing you need to be able to think about is what direction is it be asking me about? All right, so here we go. So it talks to me here about iron reacting. So as I look at this reaction, going forward, does it show iron reacting? Yes, it says iron plus oxygen, so iron is reacting. Iron is reacting with oxygen. So yes, it's in the forward. So I would always write down your arrow of direction. You know that this particular question is asking about the forward reaction. So then I will take 4.00 moles of iron. Okay, and I know from my balanced equation, because what we have done here now with the delta H value in a balanced equation is set up ratios. We have these coefficients here, all can be set equal to the delta H. So iron, 4 moles of iron to negative 16, 3 moles to negative 1652, 2 moles to negative 1652. So down here then, I will say 4 moles of iron equals negative 1,652 kilojoules. Now it's negative because it's in the forward direction. So when I do my math, I get 1,652 kilojoules of iron. Problem B. Again, we must consider what direction is this reaction. What direction, is B asking for? It's asking for iron oxide produced. Does this reaction show iron oxide being produced? Yes, it does. Here it is. It's on the product side, so it's being produced. So therefore, I'm considering this reaction and using it in a forward direction. So then again, I would take what I'm given, 1 mole of iron oxide, iron 3 oxide to be specific, is equal to, then I know for every 2 moles from my balanced equation of Fe2O3, there's negative 1,652 kilojoules. When I do that math, I get negative 826 kilojoules for my answer. Okay? Simply do the numbers across the top, multiply the numbers across the bottom, and divide the two. Going on to part C. Again, we must ask ourselves, is this reaction that we're being asked about in a forward or reverse direction? So here we have iron reacted. So this shows iron as a reactant. So I'm still describing this reaction in the forward position. To make sure we're clear, every problem we've done so far has had one starting possibility or has an ending from only one ending possibility. What do I mean by that? I have iron here I have iron here reacting with excess oxygen. Well, excess oxygen tells me then that I'm not going to start with that because everything, recall, must start with the limiting reactant. So now we're going to start with what we're given. 1 gram of Fe. I know there are 55.85 grams of Fe for every 1 mole of Fe. Now, where am I getting that? The molar mass from the periodic table, because I needed grams to cancel, because my relationship isn't between grams and kilojoules. My relationship is between the mole coefficients, so the 4, 3, and 2, and kilojoules. So I got to get my answer into moles. I did that, and now I know from my balanced equation 4 moles of iron equals negative 1,652 kilojoules of iron, because it's in the forward direction. And then I know the answer here is negative 7.39 kilojoules. Try to make that kilograms. Kilojoules. All right. Example D. Now, example D is a little different because we have 2 starting amounts. We have grams of iron and grams of oxygen. So we do not know which one is a limiting reactant. We must establish that first. In order to establish a limiting reactant, we take each reactant, so the iron and the oxygen, and each of them go to iron oxide. Remember, to establish a limiting reactant, each reactant must go to the same comparison point. In this case, we only have 1 comparison point, so we'll take them both to iron oxide. So we'll start with 10 grams of iron, and we'll get to moles of iron oxide. We'll talk about why we're stopping at moles in just a minute. So we have 55.85 grams of iron for every 1 mole of iron, periodic table number. From my balanced equation, 4 moles of iron for every 2 moles of iron oxide. When I get that number, I get 0.0895 moles of iron oxide. That's one possibility, but I have 2 different starts. I got to see which one's my limiting reactant. So now I have to take 2 grams of O2, periodic table number. Remember, there's 2 oxygens, so 32 grams of O2 for every 1 mole of O2. That's just the periodic table number, the molar mass. I know from my balanced equation 3 moles of oxygen for every 2 moles of iron oxide. When I do that, I get a value of negative 0.0417 moles of iron oxide. So, which of these is the limiting reactant? I look at my comparison points, so my iron oxide, and I pick the reactant that produces the least amount. My reactants are over here. So 10 grams produce 0.8, and 2 grams of oxygen produce 0.04. So therefore, my limiting reactant is going to be oxygen. It produced the least amount. So then I will start the next problem, or the answer to the question, with that. I must start with oxygen. So now I'm going to take 2.00 grams of O2. I know there are 32.00 grams of O2 for every 1 mole of O2, again using the molar mass to get from moles to grams. And I know there are 3 moles of O2 for every 1,652 kilojoules of O2 released. When I do that math, I get a value of negative 34.4 kilojoules. Now, we didn't talk about direction here. We could have and should have. We already knew that if we're reacting iron and oxygen, then it was forward. Therefore, that's why I had a negative value for my kilojoules. All right, on to E. Again, I only have 1 start again this time, like I did in A, B, and C, so I don't have to worry about limiting reactant here. I just need to look and see what direction is it talking about. It's talking about iron oxide decomposing. Remember that decomposes means breaking down. Also remember, another academic language would be synthesizing. When I synthesize or synthesize something, it is going to form. So this says iron oxide breaking down. In order for iron oxide to break down, I have to think about the reverse reaction. Going from iron oxide here and breaking down into oxygen and iron is a decomposition. So then in this particular problem, we're talking about the reverse reaction. So I would take 5.66 moles of Fe2O3, and I know from my balanced equation there are 2 moles of Fe2O3 for every positive 1,652 kilojoules. Now, every time I write a kilojoule or a joule down, I have to pause and think about, is it supposed to be a plus or minus? I would encourage you to physically write down either a plus or minus. When I do that math right there, I get 4,680 kilojoules. That's supposed to be a 0. Absorbed. Absorbed because it's positive. If you would have this as 4680 negative, it would be completely wrong because it does not show me and you did not think about the reverse reaction. In order for iron oxide to decompose, I must think of the reaction given in the reverse order. When I reverse it, I change the sign of my delta H. All right, on to F. All right, here again, we're going to think about what direction are we being asked to think about. We are talking about iron being produced. Well, this way it shows iron reactant. That's a reactant. So if I talk about iron being produced, I have to think of the reverse reaction. So then I start with 78.6 grams of iron. I know there are 55.85 grams of iron for every 1 mole of iron. And I know for every 4 moles of iron from the balanced equation, I have 1,652 kilojoules absorbed. Why positive? Because it's the reverse. And when I do that math, I get 581, specifically positive 581 kilojoules absorbed. All right, that concludes all the examples we did in class today. I would like to refer you to this slide here, so take a moment, maybe pause it. You have a worksheet that's entitled FA Enthalpy Worksheet. It's not part of your homework packet. I actually gave it out today, so if you weren't here today, I will post it on Classroom, so you can print a copy if you wish, or write on your own notebook paper. So you will pick whatever one of these you want. Perhaps then, to make it simple, you could be purple tag. But if your favorite color is blue, then do the blue tag colors. What does that mean? That for problem 1, you will do problem D. For problem set 2, you will do the version A of the question. And then for problem set 3, you will do the B of the question. All right, so that's on Classroom for you to use. You should be ready now for a mastery quiz. Your homework assignment before you take your mastery quiz is to do 19 through 22. So that's your homework. Finish these problems here on this FA paper. So finish one of each of these from 1, 2, and 3, and then go do in your homework 19 through 22. Oh, the answers are there in your homework, and then you'll be good to go for your mastery quiz.